Hi everyone, it's a new circuit I built. It's a variable sine wave oscillator. It's this circuit here, and this is another circuit. I'm not using it right now, only this here, and it's a simple variable sine wave oscillator, one transistor, and the important element here is this coil. It's basically a variable coil. Here is a coil I can screw in and out of the coil, and I can change the inductance. So respectively I can change the frequency of my oscillator. And this is two wires, my output of the oscillator. This is the output, and the blue one is the ground. And it's this 9-volt adapter supplied circuit. So I will show you what happened with this oscillator with my scope, and then we'll connect a load to my oscillator. Basically it's this capacitor and this coil I wound, and I apply some sticky tape around it to prevent unwinding. Here you can see the wire. So let's first see what's happening with this oscillator. Turn on my scope. And start the circuit. So here's my probe, here is the ground, and the output. So this is the output of my oscillator without load, and I can change the frequency. So I screw in the core inside of the coil. So that's the lowest frequency I can produce with this oscillator. And let's unscrew the core. So as you can see, the wavelength gets shorter, so the frequency getting higher. And this is the highest frequency I can get with my oscillator. The core is out of the coil, so the inductance is less and the frequency is higher. Here is interesting. I want you to keep in mind, my scope is, let's try to focus. I'm not sure that you're gonna see, but my scope is at 2 volts per division. So here we have 1, 2, 3, 4 divisions, and let's check that if there is higher voltage. So basically here is the highest voltage my oscillator producing, and it's about 1, 2, 3, 4, 5, 5.5 divisions. So it's a 2 volts per division times 5.5 divisions. It's about 11 volts. 11 volts peak to peak is my higher voltage my oscillator produce, and if we change the frequency there's a slight decrease, but the highest voltage this oscillator produces is about 10 or 11 volts peak to peak. So okay, I will show you what happens when we attach a load across the output. So I'll pause the video and connect these guys over here, this capacitor and this coil. So I connect the coil and the capacitor with these two wires, the output of my oscillator, and attach the scope here. Okay, I'm ready. So my scope is still at 2 volts per division. So we damped the signal right now, and you see it's about one division, and the core is out of the coil, so this is the highest frequency I can produce. So I can put the core back in my coil, and let's tune the circuit. So you see that there is increase in voltage about here. Okay, here is the highest voltage I can get. So this is a resonance right here. The output is the same of my oscillator, and my setup here is still at 2 volts per division, but we see there is a higher voltage than before when there is no load. So it's about basically 8 divisions times 2 volts. That's about roughly about 16 volts peak to peak. Yes, because it's resonance, even higher than without a load. So if you see, if I increase the frequency, we're going down in voltage, and if I decrease the frequency, we're going down again, and this is the lowest. This is the lowest frequency I can produce. You see, the core is getting inside all the way inside of the coil, and you see what the voltage. So I can tune back to resonance. And here we go, we're going up, and yes, it's resonance again. If you go higher in frequency, the voltage is going down. So that's the point where we hit the resonance. Oh, here. So it's interesting that we're getting higher voltage even without load. In books they say if you have a parallel circuit resonance, you can get higher voltage than your generator input, your circuit. so I think it might be interesting. Thanks for watching.